Okay, so evaluation. I mean, we've heard a lot about evaluation already in the morning, about results, and yeah, so I'm not going to repeat that now. This is now going to be about the tools and resources that put us, or also you, hopefully, in a position to do your own evaluation, so that you can judge for yourselves what is best for you and your application, what you'd really like to have in the end. So in Impact, I mean, we've heard that many tools were improved, but that's basically one of the, or that's part of the major outcomes. But also a major outcome is that we have now like a complete evaluation infrastructure that is tools that can help you doing your own experiments. Okay, so just I mean, you can't possibly miss it, right? The forward is like that big. But okay, quick overview. First of all, a few words about digitization workflows. So basically, where we want to do evaluation and all that. Then a bit more about performance evaluation in general, what is required to do evaluation. And ground truth, we've heard that term so many times now. I'll explain hopefully a bit more what that is. Evaluation tools, that is the actual software that takes ground truth as input and results of some method and then produces some meaningful numbers. And then two examples, segmentation layout and OCR text, to show you a bit what we are measuring and then how you can interpret the results. Okay, digitization workflow. I mean, obviously, your workflow might be slightly different. Maybe you have some extra steps, or maybe something is missing here. But in general, I mean, it starts with scanning, and whatever goes wrong there is hard to recover later. You all know that. And, well, still, you can try in image enhancement then to, well, improve images. Well, first of all, to prepare everything so that you get better results. And usually, depending on your workflow, the output of one step is then the input of the next step. So that means at every single step, you produce some output. And for that output, there should obviously also be some like an optimal solution. Okay, I mean, page splitting, quite common if you're using an overhead scanner to be more efficient, and you get 2 pages at once. Border removal, also if you don't use a flatbed scanner, and usually you get a lot of I can say things that don't actually belong to the page. Dewarping, we have different types of dewarping here. Something that is to remove page curl, which is mostly if you use an overhead scanner, and you get something like this more a cylinder model, but also things like arbitrary dewarping. If the page was, due to humidity, maybe then a bit distorted and all that. So anyway, at all those stages, you get perhaps models, how to transform the input into some output. And you should also have something like an optimal solution. I will come back to that later. So what we really should take from here is that you can, well, first of all, individually evaluate every single step. But of course, you should also consider the whole workflow. So, I mean, the complete workflow, this is obviously important for the final result, but for the IT guys or for tools developers, it's really important to see what happens at every single step. So that's why we shouldn't just consider the final OCR result, but we should also have a look at the things that happened before. And of course, down here, layout analysis, I mean, all this plays an important role in the final results then. Okay, so what do we need for a performance evaluation environment? Obviously, it all starts somehow with images. So obviously we need some sort of image repository, and as for the selection of images, it is really crucial that this is representative of what you're trying to digitize or to recognize, and so on. So it is not just to have some images, but that should really reflect the kind of material you're going to process. Okay, then, I mean, that route, it's obvious. You apply document image analysis or optical character recognition tools, and you get some results. And yeah, of course, now what you do next, you need to compare that, and that's what I mentioned before. We need something like the optimal result. That's what we would expect the method to do. And that's, in general, what we call ground truth. So ground truth is not necessarily just the final text. It is also, say, regions for segmentation. It is also, or it can also be the ideal binary image, or it can be a developing model, maybe some grid, that you would use to map the distorted image to a perfectly straight image. So ground truth can be all that. It's not just text. I'd really like to emphasize that. Okay, then you need tools that take the output and ground truth and then basically check for the correctness of the result. And in order to do that, we also need something like a common format, so that it is the output of some method is compatible to the ground truth. I'm sure you've heard about TEI or Alto and so on, but they are not all the same. And it's really, I mean, to do a full-scale evaluation, you really need a format that covers all the aspects of layout analysis and OCR. So for instance, in Alto, there isn't really a concept of glyphs. So if you want to evaluate the character segmentation, how a word is split into characters, you can't really do that using Alto. So that's something to consider, the importance of a common format that can express all the things you want to evaluate. Okay, so evaluation metrics, that basically means what do you want to measure? So what types of error, for instance, would you consider? Say for OCR, we've heard that many times now, it's the character accuracy, it's word accuracy and all that. Or for segmentation and layout analysis, it would be missed regions or misclassified regions or merged regions, wrongly split regions. So that's basically the types of error you would measure. So this is more or less a very objective thing. It's what you find in the output of some method and the ground truth, and you can compare that. But that still doesn't really tell you how good a certain workflow of tools is suited for what you want to do, because you're not doing that just for fun, because you really want to do something to the material in the end. And that's why we should always consider scenarios, so to put that into context. For instance, if you want to have full text search in the end, then obviously it's important to get a high word accuracy. If you want to do some structure recognition, say, so you want to discover all the headings and page numbers, and you maybe have to emphasize those things more, put higher weights on such things to then decide if that is a good workflow for you or not. So if you've missed all the page numbers and all the headings, then that result obviously is not very good for structure recognition. Okay. I'm now going through those individual aspects a bit more in detail. The image repository, so in Impact, we created really a very big collection of material now, and it's all accessible through that website. Basically, we have metadata for all the documents, and of course the images are there. We standardized on TIFF compressed with LZW, but that's not really so interesting because formats can usually be converted from one to another. More importantly, we also have ground truth for quite a substantial amount of documents now, and with ground truth I mean the actual segmentation, that is region outlines, the actual text inside the regions encoded in Unicode. I'll come back to that in a bit. And also reading order. So it's a ground truth in this case is not just the final text, it's more information. Okay, I mean the repository, it's searchable, so you can search for some image characteristics. Maybe you're interested in say only grayscale images, and then it would retrieve all those images, or maybe some documents from a certain period of time. All that, and then you can also make selections. We have such a card functionality, so maybe you want to, combine a number of documents and then use them for your own experiments to evaluate some workflow and see how that performs. The data sets, we have close to 700,000 images now in the repository, and quite a great number is more or less organized in data sets. So that's basically for 10 libraries what our partners thought as representative of their holdings. And this is really a very, very valuable resource for researchers also, and also, of course, for the libraries to actually see what they have and then what are the priorities to work on, say. Okay, for that we created some smaller subsets, the so-called demonstrator sets, and that's basically those documents for which ground truth was produced or still is being produced. We have now, that was end of last week, 36,498 documents, but still growing. I mean, some documents are just in the process of being approved and will be uploaded very soon, so we are very close to this number, and that will be finished very soon. Okay, we also have some working sets here. That's basically smaller collections, some showcases, or some collections for some very specific problems like typewritten material, or something that someone who's working on dewarping would need. Dewarping sets, some challenge sets with very, very complicated layout and maybe heavy image artifacts and so on. Okay, maybe interesting also the use statistics. That's only how within the project the material was used. We started basically tracking that more or less like 1 year ago, and already over 5 million thumbs were browsed. That means libraries or the research partners were basically going through material and to see what are the problems, how can we have good test sets and all that. Okay, and also a great number of images was actually accessed then, full quality images. That means that it wasn't just the thumb that was browsed, but really, someone had a look at the actual image. Direct access calls, that's related to what Clement said before. That means that from within the workflow, from the framework, that images were directly accessed from the repository. Okay, if you add those two numbers together, you don't get the 810,000. That's because also some screen copies and other things. Right, so ground truth, I mentioned that many times now. How did we actually create ground truth? And the main tool for that was and still is Aletheia, which is Greek and stands for the truth. So a very appropriate name, I guess. And you can do a lot of things with that tool. It's actually quite mature now. Many service providers are using it, and we also get requests from other researchers and from other groups to work with that tool. You can record quite a lot of information, things like the page border here or print space. Günter Mühlberger will say a few more things about that later on, why that is useful. Of course, all the regions, so say a text region here, another here, separator, and so on. plus metadata. That means you don't just get the coordinates, you also get information like, okay, this is a heading, this is a separator, very, very detailed, and you can see that here. Of course, since we are also doing research on more specific problems, we can actually mark text lines, words, and glyphs really down to that very detailed level, and then record the text, the actual Unicode text on all those levels, and also reading order and even layers, even though that's not really in use yet. But you know, sometimes we have things on top of each other, like a stamp. So that would be overlapping regions by layers. You know, you can actually express such things as well. All right. So I already mentioned that this tool is in use by many service providers already. But sometimes they prefer not to start from scratch and then draw regions around, even though we have very nice shrinkers, which, you know, you just draw a rectangular region and it really shrinks to that outline very closely, very neat. In many cases, I prefer to start from some pre-produced files. That means ABI, for instance, FineReader, produces already very good results, and I just have to correct a few things. So as for ground truth production, we were really pre-producing everything, and then the service providers, in most cases, would just correct that. We also have a so-called ground truth validator, which is very useful when it comes to quality assurance. As you can imagine, for 50,000 images, it just happens that something gets forgotten. For instance, you've marked 5-6 regions here. But then, you know, when it came to typing the actual text, maybe you skipped one. So that is things we can automatically check. And also say if something was missed out in the reading order here, then that ground truth validator, it's integrated in that graphical user interface. But we also have it as a standalone command line tool, which can be run on thousands of pages. So it produces you like a report of the potential problems. Basically things that maybe need checking and things that, you know, would not really fulfill the criterion of being ground truth, like, you know, close to 100% correct. Yeah, some more details about ground truthing historical documents. I mentioned that already, full Unicode support here, including special characters for historical documents. So we still keep encountering new, or I should say very, very old characters, basically things the service providers just can't type. They don't know what it is. So in those cases, we usually get in touch with language experts, and then they try to clarify what it actually is. And if it's something that really is not in Unicode, and then we basically maintain a list of such things and introduce them with that mechanism of Unicode of private use area characters. You might know about that. And we also check against the movie recommendations at the Medieval Unicode Font Initiative. That's also not necessary of Unicode, but they have also spent a lot of time and effort to, you know, maintain such lists. So since you can't really type that without some extra help here, we have this virtual keyboard that basically reflects our list of special characters so that you can, or the service providers, whoever is doing that, can type that. And also our font used here in Alifia contains those characters so that you can actually see the text as it should be. Reading order is also something that so far isn't really solved. So for instance, in Alto, there's only a simple sequence of elements foreseen, but in many documents we encountered more complex things like, you know, this goes from here to there and then down there, but this is more or less, you can't decide when to read that, so it's not strictly in any linear reading order, so that's why we had to introduce groups of unordered elements alongside ordered elements. Of course, then for evaluation, you need to somehow get a path through that document to decide whether OCR has output valid reading order, which is also very tricky, but those things were actually solved in the scope of impact here. Okay, this is to reiterate the fact that ground truth is not just text and not just region outlines. It can be much more. So for deskewing, maybe it could be just the right angle that you have to rotate the image to be perfectly straight. For dewarping, depending on what kind of distortion it is, it could be maybe a cylinder model here, or maybe some grid model which reflects, the transformation from that warped image to some perfectly straight representation. For border removal, the ground truth can be that polygon here, for instance, separating the background from the actual page. Or binarization can be either a threshold, maybe in a very simple case, or it can be also the perfectly binarized image. Our partners from NCSR in Greece, they developed a method that is based on skeletons to produce perfect outlines of such characters. And then you can use that to compare the output of a binarization method to that ground truth. The format, very important. I mentioned that already, that the existing formats weren't necessarily, powerful enough or accurate enough to reflect all that. So Page was more or less also developed in the scope of impact. And it's two-level architecture. We have some root structure, which then can link basically those individual ground truth instances. The most important thing for us is still the actual page content, which is the region outlines with text and reading order, because that's what is really interesting in most cases. Okay, and what is also very important, this can be used to represent the output of some OCR, but also ground truth. So that means those two things can be compared straight away. And there are some converters also involved. The schema is publicly available, so if you want to use that format, you can just check the schema and then integrate it in your tools. There are also some C++ libraries for developers, so they can easily output valid page instances and then use the infrastructure that Impact provides for viewing ground truth and for evaluating and so on. Evaluation tools, so that's the piece of or the pieces of software now that really take the output of some method and ground truth and then compute results. So mentioned before, we've produced many tools. The probably most impressive or important ones are those for segmentation and layout and for OCR text, and I will explain them, how they work internally a bit more in a few slides. So you can see here, this is a graphical user interface again. So most of those tools come in two versions. One is a graphical user interface for, say, some developer or some IT person who really wants to track down some problems and maybe find bottlenecks and so on. But we also have the command line tools, which are integrated in the framework, so that can run on thousands of images and then produce numbers so that you get more statistical results. All right, so segmentation and layout analysis results, I should say. Just to quickly show you how that works, or at least to give you a glimpse on the idea. What you get after segmentation and layout analysis, which basically is not just to return the region outline, but also to classify what type it is. Is it an image? Is it a text region? And so on. So that is somehow stored in the ground truth, and the result is something similar. Obviously, ideally, those two objects would really, fully overlap, but in reality, that quite often differs. So what we can measure as for our metrics is different error types, and the most obvious thing probably is missed regions. So that means there's something in the ground truth and it's not overlapped by any region result at all. So that means segmentation just missed it completely. Slightly less severe would be partially missed regions. So that means some part here of the ground truth is not overlapped by some segmentation result. Another type of errors would be split. That means we have one region in the ground truth and the result is two or more regions in the segmentation output. Misclassification basically means that the ground truth it has one type assigned and the segmentation or layout analysis then produced or marked it as some other type. So very, very severe problem is if some text is classified as image, because then it would never be sent to OCR and so you basically lose that content. Merge errors, that is when we have separate regions in the ground truth and they are overlapped by one or more regions of the result. And false detection is usually not a big problem but can happen. That means that segmentation found something on the page that actually isn't there. It's usually noise also, but it's not a big problem. Okay, those things can then be even specified further by taking into account things like reading order. We can differentiate between allowable errors and non-allowable errors. So the reading order in this case, even though this has been merged into one region, thus it should be only two, is not really disturbed, whereas in this case, of course, always assuming that this is a reading order from left to right and top down. So in this case, that line would continue from here to there, and again, so that would create problems then if you really want the whole article in one nice object. Just an example, I already got the sign, there's not much time left, but so say this is ground truth, everything is marked. We have different objects here, page number, for instance, header, paragraphs, image caption, and so on. And layout analysis produces perhaps something like that. On the first glance, it doesn't look that bad, but really depending on what you want to do with it, it can be bad. Because, for instance, the page number was missed here. That means if you want to do some structure recognition, it might be really, really a bad result. And then here, something missing from the header. Okay, that was not very problematic, but say here misclassification and so on. So this is basically what the tool does internally. It computes all those types of errors, and then it detects this as a miss region, a partial miss. Those things have been merged together. This was split, and here that was misclassified. So the caption is a paragraph now. If you're doing image search, maybe you need to find image captions to look for keywords in there, so that can be a problem. Maybe it isn't. So that is basically the metrics, the things, the errors we are measuring. And then how to put that into context is the next step. That is what we call evaluation scenarios. And I think I'll skip the OCR text because we heard that before. Basically, the tool to evaluate OCR results, I mean the actual text, computes the commonly accepted measures for character accuracy, word accuracy, and then specific refinements. So we heard that before. The character accuracy is the number of edit operations. Actually, very important is the minimum number, because you could just delete the whole thing, replace it. That would be like 22 edit operations. Never mind. It's always the minimum. So from here to there, you would have to substitute this, for instance, and add that. And here's also something wrong. So you maybe get 3 errors, and you come to then the actual character accuracy. This can be broken down into character classes, say for lowercase characters, for uppercase characters, white space characters, which perhaps aren't that interesting to you, and so on. Word accuracy is very important. We've seen that before, because in this case, there's an arrow here, an arrow there, so those two things. So that means it's still an accuracy of 33%, but it's not really useful because that is actually a stop word. So when it comes to some full text search or keyword search, that wouldn't really return very good results. Also important is rejected and suspicious characters. Usually OCR engines operate with probabilities and confidence values. So it's better if the OCR says, okay, I really don't know what character that is or word that is, and then you can correct it yourself, than just putting something, which would be a substitution error, without letting you know that it actually wasn't really sure. And finally, correction effort. We also heard that maybe you're more interested in how much effort it would be from some OCR result to get perfectly 100% correct text. So there's something like the figure of merit and so on, which puts that into context. To conclude, sorry about rushing through this, but I think we just made up for the initial delay. Two things. We have metrics. That means what do we measure? The types of errors, the affected regions, say, the size of the area, and so on. That's things we can just measure. That's very objective. And then we have scenarios. That means we put some weights on specific problems, so that you can then come to some overall success or error rate, which basically takes into account all those things. So it's always a big problem if someone asks you what is the best image format, the best resolution, the best whatever. It really depends on your material and what you want to do. So, and this is what I was trying to emphasize here. It really depends on what you want, and then you can define your own profile here for evaluation. You put it in context to what you want, and then you can, of course, produce some final numbers here, that you can present to the decision makers, or maybe you're the decision maker yourself, and then say, okay, that's the best workflow configuration, and so we can get the best results from all this. Okay, thank you very much. If there are any questions.